In this tutorial, we're going to be looking at geometry primitives. These are the basic building blocks that you'll be using in many of your networks. And you'll probably find in Houdini that you spend more time picking them apart and tweaking them than you would in a normal 3D program. So it's worth looking at some of the different options that are available. Open a new scene and hit Tab and type Geo to create a new geometry node. Remember, this is our transform node and most of our networks take place inside these. So double click to open it. Hit Tab and take a look at the primitive menu. You'll see that there are many primitives inside these, and some of them are extremely complicated, such as the L system, which you could spend months on alone. We're just going to be looking at the geometry, and there are two types here. The first are the quadratic primitive shapes. So these are the circle, the sphere, and the tube. These primitives are very simple and they're described by mathematics rather than consisting of polygons. Each one has a single vertex at the center. The advantage of these models is that they're extremely light. So if you're working on something that requires thousands and thousands of objects, these would be a good thing to use. The disadvantage is that they don't behave in the same way polygons do. They don't have surface points. So if you're going to be processing them further, then you probably want to convert them to another type of object, such as a polygon, and then you can see the sort of parameters that you would expect on a polygon object. The next group of primitives that we're going to look at start out as normal geometry. So these are the cube, which in Houdini is traditionally known as a box. It's only recently that they've put a cube in there as well, and in fact they're exactly the same thing, but will allow you to type cube when you're searching for it. The torus, which should be familiar to anyone who works in 3D. And finally, the grid, which we'll be focusing on today mostly. A final node to look at is the Platonic Solids. This will create a series of geometry types that consist of sides that are all of the same type. So there are 1, 2, 3, 4, 5, 6 of these. And then, as I guess a bit of a joke, and because it can be useful as a stand-in geometry, we also have the utility pot, which is not a Platonic solid. So there may be some situations in which you want to start with one of these shapes. Now let's go back to the grid. Now, using the grid, we're going to look in a bit more detail at the different primitive types. The default for the grid, and in fact any of these 4 objects, is a polygon. First of all, I'm going to select a point within the polygon and move it, and this will make things a bit clearer. Now you'll see moving one point automatically creates an edit node. So long as this node's active, you'll see we've changed the shape of the polygon slightly. Now let's go back to the grid and change our type to a mesh. you'll see there's a very subtle change in the way the polygon is displayed. This is easier to understand if we turn on the normals. So these little lines show the direction of the point normals. Within a polygon mesh, you can see that they form little clumps. In fact, the normals that are being shown here are the vertex normals, so there's one for each face, which is why you can actually see 4 little lines there. And they're all pointing in the same direction. Now, if we switch to polygons, you'll see that some of these are pointing in different directions, and we start getting hard edges. The reason for this is that a polygon mesh is actually using a formula to describe the way these polygons go together. And it's a slightly simpler and faster way of displaying polygons. So it's describing all the normals as a single unit, whereas the polygon allows us to describe them as individuals. Now, if we turn our quadrilaterals to triangles, you can see a bit better what's going on here. The polygon, by default, is actually a collection of triangles. When we display quadrilaterals, we're just hiding some of the edges between those triangles. The mesh, because it's a mathematical formula, is actually working on quads. The next primitive type are nurbs. Now, in fact, the nurbs and the mesh are more closely related. The mesh is very similar to a nurb with an order of 2. So if we turn these down, you'll see we're actually looking at something very similar there. The nurbs uses points to influence the position of the surface, and then draws smooth curves between those. So in fact the points don't have to sit on the surface of a nurbs mesh. You can see this is some distance above it. If you're interested in working with nurbs, I would suggest it's something you go and look into, because there's a lot of information out there. I'll mostly be working with polygons, because polygons are what we use in video games, and engines are designed at the moment to run these efficiently. After nurbs, we have a bezier curve, which is in fact similar to nurbs, but the mathematics behind it is slightly different. One notable difference is that you can have hard edges in a bezier. So you can have a broken line. So nurbs at an order of over 2 are always smooth. The next option for our grid is to display it simply as points. Now, you might wonder why we would want just a grid of points, but in fact, grids are useful for many things you wouldn't expect in Houdini. For example, these points could be emitting particles. Or they could be used as positions to place other objects. And then lastly, we have the Polygon Soup. The Polygon Soup is a terminology specific to Houdini, and it's their way of compressing polygons in order to make them faster and more efficient. You could see it as something similar to the TIFF format in images that allows Houdini to store things more efficiently. If you're changing the topology of an object, then this isn't supported by the Polygon Soup, but you can convert things backwards and forwards between normal polygons and nurbs and beziers and other kinds of geometry. So that's something that you could look at if size is a concern in your network. So I'm going to go back now to polygons, which is what I work with most of the time, and we'll have a look at the connectivity. So we can display simply rows or columns as edges. This could be a good time to explain to you the concept of edges within Houdini, which many people find very frustrating. Basically, unlike Maya or Max, an edge isn't its own type of component. In fact, an edge is a type of polygon that only has 2 dimensions, and it behaves like a polygon. Usually your component tools will work either on points or polygons and not edges. There are a few exceptions to this, but be aware that an edge isn't its own distinct type of component within Houdini, which can lead to some frustrating and odd workarounds. So what you're actually seeing here is a collection of 2-dimensional polygons, and we can run them in both directions at the same time. We've already had a look at triangles and quadrilaterals. You can switch the direction of the triangles. It's something that, there we go, something that might work better for you, or you can split them up completely. And in fact, this probably gives us the nicest result for our little shape that we've made. Now I'm going to switch back to quadrilaterals, and I'm going to show you a handy way of keeping the density of your grid consistent. So here we're going to be referencing values from one set of dialog boxes into another. This is something that I'm doing constantly within Houdini. When I first started using it, I saw this as a fairly specialized thing to do, and I've since realized that it's absolutely core to the way Houdini works. So I'm going to be showing you lots of ways of doing this so you get used to it, and it's really simple. So what we want is the size of our box to drive the number of divisions within the grid. So I'm going to copy this parameter, so that's the X size, and paste it into columns. But instead of just pasting the value in, which would be 10, as you see, I'm going to paste a relative reference. So now the value in here drives the value in columns. If we use the number ladder, you'll see that as it gets bigger, the number of columns changes, and we'll do the same with rows. Something that's quite useful to know is if you right click in the box and hit paste, it will overwrite what's there already, whereas if you click inside the box first with the left mouse button and then paste, it will paste it in wherever the cursor is. So this allows you to insert a reference inside a formula that already exists. So now you can see our rows and columns stay relatively consistent. And finally, I'm going to add a parameter that allows us to change the number of rows and columns within this size. So we click the little gear symbol and go to Edit Parameter Interface. And we want to add a float, which we can use to multiply by our rows and columns to increase the numbers. So let's call this density and change the parameter name as well, which is what we use in our expressions. It just makes it a bit clearer to see what's going on. The default will be 0, so we'll change that to 1. So if we're multiplying it by our rows and columns, that will give us no change to start with. and hit apply. You see density appears here and accept. And now we're just going to do the same again where we copy this parameter, click inside the box and paste a relative reference to the density. And the same for columns. Now you can see as I increase the density, the number of rows and columns gets bigger, but it still stays the same relative to the size of the grid. Now let's delete our edit and take a look at some examples where we might use our grid. First of all, for any node, if you want to see some examples, the best place to start is to open up the help for that grid, which is this little symbol with a question mark on it. So in here you'll see a lot of information about the grid geometry. And then at the bottom there's a list of examples. The first example you'll get is designed to show you information about this node, so it's specialized for this node. These unfortunately aren't available for every node, but some of them will have them. And then below that we have all the examples that include this node, and because the grid is so fundamental to Houdini, there are absolutely hundreds of them. So just to show you how they work, I'm going to load up the grid basic, which is designed to show off the grid. If you hit load, it will create a new geometry node within this scene. If you hit launch, it will open up a new version of Houdini, but we don't need that. And that's not an error that we need to worry about. Now, go up to the object level, turn off some of these displays, and you'll see there's a new object called Grid Basic. We can have a look in here. Everything's turned on at the moment, so if we turn these off and switch them back on again, you'll see there's a little bit of information for each one, and in fact what you're seeing here is some of the examples that I showed you earlier of the different types of grid mesh that are available, and a bit of explanation about it. So I'm going to delete that and go back to our grid. So a quick look at some of the things we might use our grid for. We can use it as a particle generator. So if I type particle in here, this has an option for a particle source. So we'll connect the grid up to that. If you remember, if you hit the little pink bar here, it shows you a template version of the grid. And now we hit play. You'll see there are particles being created, but they're not doing very much. Let's add a force. Now you can see our grid is streaming particles into the air. The particles are actually being created in the same order as the points, so you can see it starts with 0 and so on. We have an option in here to modify the source geometry. Let's turn the force down a little bit. And now you'll see that the particles are actually changing the shape of the geometry. Let's put a little bit of turbulence on. So we'll start to do some interesting things with our plane. Another thing we can do with our grid is paint on it. So let's use the paint tool. There are some tools that allow user interaction. The paint tool is one of them, and you can find these by hitting enter, and you'll see you get a message here. Left mouse for foreground colour, middle mouse for background colour. So there's our foreground colour. Let's make it slightly more interesting. And make it a bit bigger. There we go. And middle mouse for background colour. One of my favourite grid nodes, and one that anyone who's played with Houdini will probably be aware of, is the mountain node. And this uses fractals to allow you to create landscapes from your grids. So there's quite a lot of options in here, and we'll be looking at the mountain node in a lot more detail later on. For now, we'll just play around with some settings. Let's turn it down a bit. Now, here you can see why having density is useful. So we can wrap this up a bit. See some of the detail in here. Turn up the roughness a bit. And now let's ramp our density right up. One thing you might not be aware of is the minimum and max values that you set up for the parameters only control the input slider, so you can actually make this a lot higher if you want. Let's make it 15. Let's see, we're getting something nice and dense there. So that's as much as I'm going to cover for now with the grid and these other primitives. You can see that the primitive types that we looked at for the grid are in fact common to all of these objects. And now that you understand a bit about them, we'll be able to start building on them and doing some interesting things with our networks.